Hello, everybody. So welcome back. Okay, so we are now doing the lab. So these are the 4 files that we have posted in the on Blackboard, and these are the files we're going to be briefly talking through. So we have here two. So firstly, we have the RMD file, which is here, which is a standalone file that essentially can be knitted together to a PDF or Word document here again. Gives you an overview of what needs to be done. We have, in addition to that, we have here the SEV file, the aforementioned SPSS data file, which we will be opening using the Haven and the Forum package. So that's something that you would come across quite frequently, I presume. And then we have a Lab 4 class and the Lab 4 edition. So these are files that have been developed by Marcel and Bino. Okay, so let's jump right in. Okay, so we're doing the Lab 4 class. So I talked about RM list equals ls. So this is how you clean your entire environment and you basically get it entirely wiped free. Then Bino seems to repeatedly do set working directory. I usually try to avoid it, but okay, we can do that. So I showed you last time how to essentially, oh, I just realized I'm not sharing my screen. No, I'm sharing. All right. I showed you, okay, so RM list equals ls. We talked about that. Then we have set working directory. I will be quickly showing how you get a path name. And I think I showed it before, but I'm just showing it again. So this is set. This is a Mac. If you have your folder, you create a folder, you have the lab folder, you copied your actual file, the file that you want to address in R. You click on it, compressing control, you get this actual overview, and you press option. It changes here to where you have copy and enhance lab4.saf as path name. You take this as a path name, and you are essentially able to then copy paste the path name. So here it also takes the actual file name, which you can here in this context delete it on the file name. Good. So this is how you change your working directory. So you run every line now with Control and Enter. This is the same for Mac and Windows. Control Enter will run the line. So again, if you select a certain part of the line, it will run only that certain line, which here, my name obviously doesn't make sense, it's not an R function. If you take off the selection and you run the whole thing, it will run the entire line. You can also select the line, obviously, and then the same happens. If you want to mark a line, you can usually do this by just clicking here in the line and you get this red dot. So this is what you need to reuse it. Data empty cars will load the empty cars file. And here's what I was referring to before as commenting. So please comment on all these things. It's just it makes it much easier to have everything commented. So data empty cars will download the empty cars file, which essentially is here. It's a Motor Trend US magazine, comprises fuel consumption, 10 aspects of automobile design. So it's essentially it's a file to play around. And R is full of these files. So they have various files. And if you go on the open intro page, which I believe I've added to the syllabus, you can look all of these up. Not all of them, but a few. So there are a lot of hidden files and all kinds of files in there, ranging from flower sizes and petal sizes of flowers to airline data, airport data. What else? There was Titanic casualties, and so there were a couple of really interesting files and files that essentially make it a point and allow for you to really have like hands-on experience with various data structures and various applications. So with dim, you get dimensions of every object. So here we have the empty cars, it's 32 and 11, so 32 observations of 11 variables. Had empty cars gives you the first 6 entries. We remember that had can also be expanded and can give you the first 20, for example, but we leave that for now. So had gives you the first 6, then we have summary. Summary gives you the summary of one specific file. So here you are variable, here you get MPG, you essentially get the minimum. The first quartile, which is below the first quartile, you have the lower 25%. Between first quartile and median, you have the second 25% of the data. From median to third quartile, you have third 25%, and then you have the highest quartile is greater than the third quartile threshold of 22.18. Don't forget about that. Here you have a histogram that you can run. The histogram essentially is showing you here the frequency as a function of your MPG entries. If you change the breaks, you will have more breaks and you get a higher granularity of your data. That's also sometimes very important and very nice to show in different breaks. So here you get 20 breaks. That gives you a smaller bin size. It gives you an increased granularity of your data. If you run table and T-cars AM, so this is automatic transmission versus manual transmission. So you have 0 versus 13. So automatic transition here is 19 versus 13. So automatic transmission is here 13. So if you are running now, fit1 is here that they prepared this miles per gallon as a function of automatic transmission, meaning that there is, with automatic transmission, there is a higher probability to have more miles per gallon. So there are more miles per gallon for automatic transmission, which is interesting. Could also hypothetically be the case because sports cars may more likely have manual transmission, but that's just an extrapolation. I don't know enough about cars. I haven't owned a car in like 15 years. So AM new. So this is now the recoding, and we have talked about the if else, right? So if else essentially is we have here if else, and if else empty cars AM equals 0, then give it a 1, otherwise give it a 0. So if we are redoing this now we do table empty cars AM new and new, we're essentially seeing 13 and 19 just in the same. So it's basically recoding in a different fashion, right? So we have 19 and 13, now we have 13 and 19. So fit2 shows now LM MPG equals factor AM new. Summary fit2 gives you essentially now the same kind of analysis as we had before, but now we see that it's inverted. So now the intercept essentially shows the miles per gallon estimate for those cars that are manual transmissions. So now with automatic transmission, the miles per gallon, no, wrong, that are automatic transmission. So this is automatic transmission, is not the reference category, with 24.9. For manual transmission reference, automatic transmission is now minus 7.245. So the coefficients are now changing, and we're seeing here exactly what I said. This is for automatic transmission plus 7.245. This is automatic transmission, and this is minus 7.4425. Then we have fit3, shows now the same situation adjusted for horsepower. As I said, the stronger the horsepower, the more likely the car is automatic transmission. So there's a confounding effect. And indeed, horsepower lowers lowers the miles per gallon estimate, which is not surprising. The cylinder number, you can, with table, you can have the unique entries. You can display this as a bar plot. This is the count as a bar plot, and you can also use this to basically depict them as actual factor. And yeah, so these are all, so this is the factor function as I have shown it before in the lecture. And by that, you can basically, make each of these entries a factor. RM list equals ls. Again, set the working directory. So we're using here the forum package. This is how the program keep it is. And this is how you basically load the enhance file in from SPSS format. So this will essentially also get you the, this is nice with the forum package. I'm not sure the Haven package would do that. So also it gets you the actual descriptions in, which is nice to have. Okay. This is this. Okay, so this is the lab forecast R file. And then we have the addition file. And this goes a little bit more into deep. So again, we're doing the same thing. So here we're doing it with the Haven package. Library Haven gets now the enhance file in, restructure that A. So what A here means, I'm not sure what A, that this is recoding. So what was done here is essentially take A, restructure it in as data frame. I'm not sure what the purpose of this is, but usually, I'm not sure they're not using it. Okay, but it emphasizes one good point. So what I usually always do whenever I have a data set, I create, particularly with large data sets, this makes a lot of sense. So at this read in stage, I usually would create a source file, which is like, that's the mother of our data frame. So I take like one that is the df source, and I would always leave that. So that remains in the memory. And then I have the working objects, which are basically queried from this larger source data file. So this source data file, I don't manipulate, I don't change at all. Everything is just going coding from the source file, because the source file, once this is in already, all the sub objects are basically taken off really, really quickly. So this is really not very complicated, and it makes a huge difference. And it makes things a little bit easier analytically and operationally. Maybe this is what they meant to show. Okay, so we have enhance, we have the A file. We have now with class, we're getting the different classes. We have it's a data frame. With head, we're getting the first 6 entries of all parameters. With names, we're getting the names of all files. This can also be ls. So ls enhance essentially is the same kind of, but it's a different order. What is nice with names, you get it in the order as they actually appear, which is important because don't forget, you can also have enhance, comma 4. You can address each individual kind of entry also by addressing it numerically. So from that end, if you want to have one particular one, you will, with names, you will know which spot it actually is. So here we have 1 is SCQN, that's the patient ID, then we have Hispanic. With 3, we have male versus non-male. So I think it makes a lot of sense to use names over ls. So then we have summary. Yeah, with summary, we talked, what is a summary? Essentially gives you an overview, histograms give you box plot just shows you the actual number. Box plot is a function of enhance. Male gives you the whole thing stratified as per males. And male, yes, no. And then we have summary for exact age, histogram. So these are all things that you can easily do. Then we have talked about table marital status. Marital status, so this requires some digging. What does marital status mean? So is that marital status 1 recoded? Okay, so data dictionary would have been helpful. Missed that one. Okay, so we just want 1, married F. Everything that is not 1 will be coded. Now we get, for those that are married, we get a 1. Those that are never married, we get 0. Table married F is 640, and then we can do a proportion table, which essentially gives you a proportion of the respective entry. In the table, race ethnicity labels, we get the attributes, race ethnicity labels, we get here. So this is the attributes, gives you the labels. So now here we learn which one is which one, and we can do the same story for the marital status. Right? So we can also do attributes, race ethnicity. Here we have married, widowed, divorced, separated, divorced or separated, never married, living with partner. We can do race ethnicity, we can do relabel here, same story. So we can do this essentially with or categorical variables. So then we can do correlations between blood pressure and age, which is here a Spearman rank. This can also be a Pearson. So here we see Pearson and Spearman kind of comparable. Plot and Haynes. So we can plot this relationship. This. Takes all of them long, the programs. Yeah. So what is interesting, and this is what I wanted to talk about last. Yes, this is, so we have 4,500 entries, so this is a lot of scatter. Lastly, I just want to show you tabli and sepli functions. So if we look at aggregate, let's start with aggregate. Aggregate is a function of, that is a base function, like very simple kind of way of looking at aggregated parameters. So we're giving with X, we're giving it the blood pressure entry. So we're saying, okay, look at blood pressure. With list, we're gonna tell it, okay, so we want this to be changed according to the various entries here. Then the function we want to employ is mean. And NA.RM means all NAs should be removed equals true. That means that all NAs will be removed from that list. If we do the supply function, the code will become different, but as you can see, it's the same kind of line out here. And it's the same result. The same is here with tabli, and I really highly recommend you to keep that in mind. So tabli, supply, and aggregate are used in different contexts. Aggregate, for example, is more of a simpler version of doing that. Supply also allows you to actually get vectors out with split functions. So essentially you can get vectors out. Tabli is more of a direct kind of aggregated value operation. Let me show you. So there's actually, so I will post some links that basically give more insight into the apply functions. Okay, so I highly recommend you to familiarize yourself with this code. So essentially we have, if we do mean enhance BP axis for enhance race ethnicity F equals 1. No. Oh, we do well. What this is non-Hispanic. Which is one non-Hispanic. With NA.RM equals true. And hence, what happens here? Just this. True. But this is 124, so this is the overall population. And if we are now restricting this to enhance race ethnicity F equals non-Hispanic. Non-Hispanic white. That's what I do. The value should be 124. So just that you see how you would build that up commonly. Because this is 124. We need to close the parentheses. So this is how you would come. C1. Okay. So this is how you would commonly build it. So you basically go mean, you take the actual vector that you want to have. So the vector is here, the actual variable, data frame, $sign variable, it gives you the possibility to indicate the variable. Then you have with the condition, and this is where what you do with these brackets here, to enhance race ethnicity F equals non-Hispanic white. And this is how you can do it. Yeah, and this is essentially what you do. And this is here. Okay, then we go down. This is a factor. So we have done including this into the actual model by building the factors and adding those factors in. You can, in addition to that, also do it by building dummy variables. And dummy variables, as we said before, is basically just done by adding and making this if else. You basically create 1 and 0s. And then you just include those 1 and 0s, and you include all of these variables. And by that, you basically get the same kind of dynamic and the same coefficients. So this is how you essentially would solve the problems, but you need to obviously adapt them to those requested in the lab exercises. So good luck with this. Let me know if any questions. I'm looking forward to your posts on the discussion board. And I'm sure you're going to do well on that. Okay, good. Have a nice evening. Bye-bye.